Hello students, today I will take the point the intensity and the energy density of the wave. Intensity and energy density of the wave. Now let us first find what is the intensity, and you know that the waves transport the energy and momentum in the medium. So they are the carriers of energy. The waves transport energy in the medium. Now here I am taking the intensity. The intensity of wave defined as the energy transported in 1 second through the cross-sectional area. Unit cross-sectional area perpendicular to the wave propagation. Wave propagation. So denoted by I. So I equal to E upon A into T. E energy, A area, and T time. So you can see that the unit of I, that is now your joule per meter square into second. So this is also watt per meter square. Joule per second, that is the watt. This represents the power. Now let us suppose that let v equal to velocity of wave, and let us suppose that this is the cross sectional area. This is the cross sectional area. The wave energy flows like this one. This is the energy. This is cross sectional area A, and the distance traveled by wave in t second. This is equal to v into t. So this length of this cylinder is your v into t. This is so much length. So now energy. We know that energy E equal to 2 pi square m omega square into the, this m is the mass, omega is the angular frequency, a the amplitude. This is 2 pi square, m is equal to rho into v, v the volume, into omega square e square, where rho density of medium, v the volume, through which the wave passes. As shown here in this way. So this V is equal to area into V into T. This is not so much. This is the volume. So we can write it to here. So this E equal to, therefore E equal to 2 pi square m. This is rho into V. So this is now rho A V T into this now your omega. N square. This is N square. N square A square. Therefore the intensity so now we put this value E in this equation. So intensity I equal to E upon A into T. This is your 2 pi square and this is your rho A V T into N square A square upon this A into T. So now this A will cancel from here, this T will cancel from here. So we are having this 2 pi square rho V n square A square. This is the intensity I. Where A equal to amplitude and n the frequency. So now you can have clear from this formula clearly. Number 1, I proportional to rho, the density of the medium. Second, I proportional to n square, the frequency. Third, I proportional to A square, and not this V, because V is the velocity. V is the velocity. So here the velocity of the wave is constant. So this is no more independent upon the velocity of the wave. So intensity I directly proportional to the density of the medium. Higher the density, higher will be the intensity, and proportional to the square of the frequency. Higher the frequency, higher is the intensity, and proportional to the square of the amplitude. So higher the amplitude, higher the intensity. It means that the intensity of the wave have this dependence upon the density, frequency, and the amplitude. Now if we take for point sound source. And if we have suppose this is now a sound source S, then we can see that the wavefront of this one will be that of circular type. So this is the wavefront. This is a spherical wavefront. If we suppose that this is suppose the distance, this distance is R, then we can have this area to be 4 pi R square. Then the wave emitted by this sound source will, this sound source will have some its power. So this can also be written for this kind of source, intensity I equal to P upon 4 pi R square. So you can see that as this wavefront spreads, this R will change. So P I is proportional to R square. P power of sound source. Power of sound. It means the intensity follows the inverse square law. It means that intensity of wave follows inverse square law. So you can have that this now intensity, here we take intensity, this now we take the distance, then this will like this. So I proportional 1 upon R square. And on the other hand, if we have this, the I and this is suppose 1 upon r square, then we will have this. So this is I proportional 1 upon r square. So it means that the for point sound source we will have this the point sound source have spherical wavefront, and if suppose the sound source is not the point one and it may be of the cylindrical type, for slit sound source the wavefront is cylindrical. So suppose we are having this as the sound source, this is no sound source, sound source. Sound source. Then it will have the wavefront like this. This is the wavefront. So naturally, if suppose that this is the area, this is the distance, this suppose radius r, and the length of this cylinder is equal to L, then we can have that intensity I equal to P upon 2 pi r L. You can see from here. Now this, as this sound waves spread, this r will go on decreasing, and while in this case the length of this cylinder, that will be the distance traveled by the wave, so that will be constant. So only here we are having that this intensity is proportional to the 1 upon r. Therefore intensity I proportional to 1 upon r. So for a cylindrical sound source or a slit sound source, the intensity is inversely proportional to the distance, while in case of the point sound source, the intensity is proportional to the square of the distance. So here it follows the inverse square law, but this is not here as the inverse square law. So this is different from this one. So this is about the intensity of the sound source. So you can see that the intensity can be increased by increasing the frequency and by increasing the amplitude and then by increasing the density. Thus intensity of wave can be increased by increasing the frequency, amplitude and density of medium. The intensity, that is the threshold of our human ear. Intensity of sound. For human ear. The minimum intensity of sound, this is equal to 10 raised to the power minus 12 watt per meter square. So this is a minimum threshold at which we can listen the sound. The maximum intensity of sound. This suppose I take this to be tau I naught and this is now I, this is equal to 1 watt per meter square. So much intensity we can listen. Beyond this, the intensity cannot be listened at all. So the loudness beta equal to, this is now 10 log 10 I upon I naught. This is the formula for the loudness, and that we can have this beta is equal to 10 log 10 and this I this is equal to 1 upon 10 raised to the power minus 12, so much, and this is now 10 and this will be log 10 raised to the power 12. So this is your 120 decibel. This is now beta. dB means decibel. This is the maximum sound that we cannot listen and at which the human brain do not work, and as a fact the man can be killed. So this frequency is intolerable. So at this frequency the human may dead. So this is the maximum loudness, and you can I will tell you later that the intensity which is up to 40 decibel, that is good for ear, and 40 to 80, then the intensity becomes so much that human ear feels the irritation, and as it exceeds the 80 and reaches to 120, then the mind of the human fails, and that causes the death of the person. So this is the intensity of 120 decibel. Here decibel, this Bell is the name of the scientist, Graham Bell who discovered the telephone, and in the honor of this scientist, the unit of the loudness of the sound is represented in terms of bell. So 1 bell equal to 10 decibel. So for that we are multiplying here the 10. So this is to convert directly into the decibel. If we do not take it in a 10, then this will come out in the bell. So this is log 10 is so much, then this will come out in only 12 bell. So if we take decibel, then this is 120 decibel. So this is what the intensity that can be at which the mind of the human being does not act and he is approximately dead. Now energy density. Energy density means the energy per unit volume of the medium energy of the wave per unit volume of medium is called energy density. Denoted by E. Denoted by U. So this U equal to energy upon volume, or this is equal to E upon V. This is so much, this is equal to U, and the unit of this one is joule per meter cube. This is what the intensity, this is what the energy density of the wave. So this is what that I have to tell you. This is frequently asked that what the factors that affect the intensity of the wave. So you can tell it to like this one. So you all like, share and subscribe the video, and also all of you remember that right from 1st June I am going to start the online classes of 11th and 12th physics, and also the crash course of NEET Physics 2021, and the regular classes of NEET preparation for 2022. So if you want to join me, then you can call me at my given number. This is 70147 and 34805. This is my number. So thank you very much. Like, share and subscribe this video.